it is strongly recommended that you already know Linux commands, because the Docker engine layer uses Linux or Linux-like commands. So if you are familiar with Linux commands, it will make this course a lot easier. Now I'll go briefly over some of the commands you might use as a Linux user. If you're already familiar with Linux, you can skip this video. So Linux is a command line interface, and so you can enter all kinds of commands. For example, if you want to know your username, you can type the command "who am I," press enter, and it shows your username. Or maybe you want to repeat some text, you can use the echo command, and that will repeat whatever you type between these quotes. So a command is anything you type and press enter, that then gives a certain output. Now Linux has all kinds of commands, and you can do, for example, interact with the file system, you can interact with files, with the network, and so on. So some basic commands is the ls command, the list command. It lists files in the current directory. You can enter a certain directory. For example, we can enter the pictures directory. And to list the files, we type ls again. To go up a directory, we can type cd ... enter. To output a file, you can use the cat command. Now, there's no file in this system, but with the cat command, you can show a file. To show the current working directory, you can type pwd. So those are some of the commands you can use to interact with the file system. To show the running processes, you can use the ps command. So ps will show you the running processes. Now to show all of them, you can do ps minus capital A. That will show you all of the running processes. Those are some of the Linux commands that you might use through the course when interacting with Docker. Docker also works on the command line, so you type commands as well. If we type Docker version, for example, it shows you the Docker version. So note that I typed Docker version here as command. So there's all kind of commands with Docker in front. You can type Docker ps, showing the Docker containers. Currently there's no containers. We can run a container with Docker run, start a container, stop a container, and so on. So if you are a little bit familiar with the Linux command line, that will help you to learn about Docker as well. Let's go over some more basic Linux commands for the file system. You can use the touch command to create a file. So touch with your file name. Let's say hello.txt. That creates the file hello. You can create a directory with the mkdir command. If you want to delete something, you can use the rm command. So rm hello.txt. If you want to delete a directory, you can't just delete it by typing rm hello, because it says it's a directory, so it needs to delete every file in that directory as well, even though in this case there are no files in that directory. So add the -r flag when you want to delete a directory. You can copy files, move files as well. So if we create a file, and let's say we can move that file, so we can say move hello.txt to documents, and now that file has been moved to documents. Now on Linux you can also do text editing in the command line. Now, different text editors for that exist. For example, nano, we can use nano to create a new text file. Now, remember we moved it to documents, so there is no hello.txt in the current directory. We can type some text. To save, press Ctrl O, so let's hold the Ctrl key and press O, enter. To quit, press Ctrl and X. To output it, we can type cat hello.txt. That outputs the text. So Nano is just one of the possible text editors only in Linux. There's all kind of text editors. So if you want to quickly edit some text, you can do that with Nano. If you want something more advanced, you can use Vim, but keep in mind that has a very strong learning curve, so you might spend a month learning Vim as opposed to Docker. And so you could use Nano right now, or use one of the graphical editors on your system. Edit files if you need to. So you saw how to create files, directories, how to remove them. You can also copy them, so we can say copy hello.txt to hello2.txt, then we have a copy. To see the contents of a file, we can say use the cat command that outputs the contents of a file. So these are some of the basic commands. Now there's also the file command, which shows you information about a file. So in this case, it shows that it's a text file. So those are some of the basic Linux commands for as far as files are concerned. So that later when you use Docker, those commands will be obvious that they are Linux commands. And so you might use one or more of these commands later on. It's recommended to learn more about the Linux command line for learning Docker. But it all should be possible to follow along. Images are instructions for what a container should execute. So if there's no image, a container does nothing. So first we need an image. We can, for example, grab the Nginx web server image, and to download that image, we use the Docker command docker pool. So type docker pool, and then the name of the image you want to download. Now in this case, we want Nginx, and with this command, it will download the Nginx image. You'll see it starts to download. Takes a moment to download the image, depending on the size of the image. So by running this command, the docker pool Nginx command, we download the latest version of the image Nginx. The docker image command allows you to do more things with images. So just by typing docker image and pressing enter, you'll see many different commands you can use. So for example, we can list the images on the system by typing docker image ls. And you'll see I have two images on the system. I have the hello world image and the Nginx image. Now, see there's with the docker image command, it shows you all commands that we can do with the docker image. So I just showed you listing commands and pull commands. We can pull an image from a repository. We can also remove an image. So let's try to remove the Nginx image by typing docker image rm Nginx and press enter. And that deleted the image. So if we do docker image ls again, you should see we only have one image now. The Nginx image has been removed from the system. So the command docker image ls shows you all images stored on the local system. So all these images can be downloaded from the internet. And when you type docker image ls, it shows the images that just exist on your computer. Now you can download all kinds of images. For example, we can pull Nginx, the web server we had before. You might want to pull complete systems like Ubuntu, and depending on the image on the software can be larger. So the Nginx image is about 142 megabytes, whereas, for example, something like Ubuntu is 77. So let's pull Ubuntu. It will take a moment to pull, in this case 29 megabytes. We can type docker image ls, and now it shows you the images on the system. So Nginx image being a bit larger than the Ubuntu operating system. But that's how you can basically work with images. Now, if you want to remove an image, remember you can do docker image rm and then either use the name or the image ID. So whichever you prefer. I'm going to just use the name. And if you press enter, it will remove the image. If you then list, you'll see that the image has been removed. There's no Ubuntu anymore in the images on the computer. So those are the basic Docker image commands. You can find all kinds of images for Docker online on the website hub.docker.com. And so if you go to hub.docker.com, you'll see this screen, and then on top you can search. For example, we can search for Linux and then select images. Then we can find all kinds of Linux images. So we have all Linux here, Ubuntu Linux, Debian Linux, Amazon Linux, Oracle Linux, all kind of different Linux-based images for your container. You can find all kind of different systems, and not just operating systems. Of course, you can search any system here, for example, Windows, and you'll see Windows-related containers, but also more old things. So if we search for images, we can find all kind of images. Let's say we search for a server. Then we can find all kind of servers like a Redis database server, a web server, MariaDB, so another database server. And you can find all kind of different images that you might use to create your container. So it's just a little note on a website that might be interesting, which is hub.docker.com, where you can find or browse a lot of images. And then to install it, you would simply type docker pool with the name of the image. So let's say we pick image here, let's say Redis. Now we know there's a Redis image, so we just type docker pool Redis, and that downloads the Redis image to your computer. Now this works for any of these images in hub.docker.com. So you can also search for trusted content or verified publisher if you want, because anybody can put images here. So maybe you only want the official ones. By selecting that, you only get the official Docker images, and they have a lot of images. So in this case we searched for server, but they have a lot of server images. You'll see 10 pages of images, or more than 10 pages of images that you might use in your Docker container. Containers are created from images using the docker run command. So that's docker space run, and then you can run a container from an image. For example, we can do the hello world image. So that will create a container based on the hello world image. You'll see this image. All it does is show some text output. That's all it does. We can see the running containers with the docker ps command. So if we type docker space ps, you'll see the running containers. And currently no container is running, because what this does, image does, is it exits immediately. So you'll see we could immediately type. There is no running program anymore. That's why when we type docker ps, it doesn't output anymore. However, we can add the -a flag, and then we can also see the historical containers. So if we type docker ps -a, so that's -a, it will show you all containers that are currently running and containers that have run in the past. So if I press enter, you'll see the hello world image using this container, and it has run about 48 seconds ago. So you can actually see which containers have been run. Every container has a unique ID and also an image. And you can see when it has been created and what happened. So you'll see status here that it has exited. Now, not all containers exit immediately. So when we run hello world, we can immediately use our system for whatever, because this container it creates from the hello world image immediately exits. Now that doesn't have to be the case. For example, you can pull a complete operating system, let's say the Debian Linux system. So we can pull the image, docker pull image, docker pull Debian, that pulls the Debian operating system image. Then you can view it if you want to with the command docker image ls. It shows you the running, sorry, not the running, but it shows you the images on your system. And what a user can do is, besides just run it once, so this would run it once, you can run it interactively. So by adding -it interactive terminal with the shell bin bash, it then sorry, the Debian should be after that. We then enter the container, so the container is still running. And so if we then open a new tab and do docker ps, you'll see Debian is currently running. But if we do it again, it's still running. It just keeps running. It's because we are currently exit this container. And so you'll see that this is a Debian system. I can list the files in the directory. For example, enter the etc directory. Again, list the files. We have a Debian version here. You'll see it's Debian 12.1. So we have a container based on the Debian Linux image. Now, it's not the only system it can run. You can run all kind of Linux systems inside your container. And you'll see that if you try docker ps again, it is still running. So a container can exit immediately, but doesn't necessarily have to. And also you can enter a container into the shell using this command. So this will create a new container based on the Debian image and then enter that shell. So that is basic containers. So far we created containers based on image using a single command. Now that is okay if you just want a very basic container, but what if you want something more complex? Then you can use a Docker file. A Docker file is a text file with instructions. And using those instructions you are constructing the container. So let's make our own container using a Docker file. First we create a directory hello world. We enter that directory. Then we need to create a Docker file. You can do that with any text editor. So if you want to use Nano, you can use Nano. If you want to use Vim, you can use Vim. Use whatever text editor you're comfortable with. So Docker file is spelled with a capital D. So Docker file. And then the first thing we need to define is the image that we want to make our container from. So we're going to use Ubuntu, or we can use Debian, it doesn't really matter. So from, and then the image you want to use as your base of your container. Let's pick Debian. Then, if you want, you can run a certain command, for example, run whoami. We can create a text file, so we can say run on Linux system, the touch command makes a text file. So let's say hello.txt. And let's also define our working directory. So work there, and then the / directory, the root of the system. We're going to save the Docker file. And now we're going to run this. We're going to build this Docker file. We type docker build -t, the name of our project. And then dot, the current directory. So that builds a container. Or sorry, that builds an image, and then we can use that image to run. So we'll say docker run. We want an interactive terminal to see what's going on. -it, hello world, and then the shell. And now we can look inside the system. So you'll see that hello.txt file has been created. It's an empty file. We didn't write anything into it. And if we look in the etc directory, you can see it's a Debian system. So we'll see Debian version 12.1. So using the Docker file, you can create your custom container. And it's easily to change systems. For example, if instead of Debian you want to use Ubuntu, you just change that in your text file. Then we run it again. We build the container, the image again. Okay, the image has been built, and then we run it with this command. Let's take a look. The hello.txt file is there again. Now if you go into etc directory, you'll still see the Debian version. However, if we output OS release, it should show that we are using Ubuntu, which we are. Now it shows that we're using Ubuntu instead of Debian. And so using Docker file, you can create your custom image based on existing image. So in this case, we use Ubuntu as base image, specified a working directory, run some commands, and also created some file. So you can really build your own container based on an image using a Docker file that is a little bit more complex. The container we made in the last lecture only created a single file, so not very useful. What we can do is more advanced containers. We can create any kind of container. For example, we can create a web server. Let's create a directory for web server. Then use your favorite text editor. I'm using Vim, but it's quite an advanced text editor, so you might want to use Nano or something if you don't know Vim. Then we can use the Ubuntu image. Once you can run an update. So that would update the system right away. We can install a web server, which could be, for example, Apache. We can expose the network port. So in order to access a web app or something over the network, it always uses a port, a communication line. So in this case, we'll use port 80. And then, of course, it has to run Apache. You can do that like this. Okay, so now we have our file. This is a simple Docker file. Let's build it. Let's build our container, or sorry, let's build our image. So now it's building our image. That starts the web server. Now it can take a moment to complete. And then we'll run it, and while running it, we'll expose the port to the internet, or sorry, to the local network, so that we can access the web server. And we do that with the -p flag. So before we specified expose 80, so port 80, and we'll also use port 80 on the exposing side. And so once this is complete, we can run the command. We can use docker run. We use -d because we want to run the container as a daemon. The web server has to continuously run. Then the name is web server. Now we use the -p flag. So on the Docker image we specified port 80, and it should open port 80 web server. So now you'll see we got a code here. If we type docker ps, you'll see a unique identifier. It's a web server running on port Apache. You'll see it's running on port 80 and exposed on port 80. So if we open the browser and we open it on localhost on port 80. So this is localhost on port 80. You'll see the output of that Docker container. And this is a web server, the Apache server running on Ubuntu. And the one that is running here. So if we were to stop the container or remove it, so we can say docker container, Docker container stop. So let's see, Docker container stop with the unique identifier. That will stop the container. Now, it might take a moment, and then once you would load the web page, it wouldn't load anymore because the container has stopped. Let's try that. We reload it, and you'll see the container is not running, so it's not running the Apache server. Now, of course, you can restart it with this command. So docker run runs a container based on web server, on the image web server on this port. If we run it, you'll see it already has a container. So we can just run it again with that name. Or what you could do is remove that container and then restart it.